Hi guys, this is IGCSE O-Level Chemistry Paper 22, Extended MCQs, June 2021, question 11. A reaction involving aluminum is shown. X moles of aluminum react with Y moles of oxygen plus 6 moles of water, producing X moles of aluminum hydroxide. What values of X and Y balance the equation? So we will have to place the values given in the table and see which of these values balance the equation. So if we have 2 moles of Al and we have 3 moles of O2 and we've got 6 moles of water producing 2 moles of Al, OH thrice. So in total we've got 12 atoms of oxygen on the reactant side and 6 atoms of oxygen on the product side. So this equation is not balanced. Next, if we have 3 moles of aluminum and 2 moles of oxygen along with 6 moles of water, this gives us 3 moles of AlOH thrice. Again, we've got 6 and 2, 4, 10. 10 moles of oxygen atoms on the reactant side and 9, 3, 3 is 9. 9 moles of oxygen on the product side. So the moles of oxygen do not balance. So these values are also incorrect. Next, we have 3 and 4. So 3 moles of aluminum reacting with 4 moles of oxygen and 6 moles of water, producing 3 moles of aluminum hydroxide. Now we have 9 moles of oxygen on the product side and 14 moles of oxygen atom on the reactant side. So this is incorrect as well. And the last one, we have got 4 moles of aluminum reacting with 3 moles of oxygen and 6 moles of water, giving us 4 moles of aluminum hydroxide. Now, in order in order to see this balance out, we will calculate the number of oxygen and hydrogen atoms on each side because this is the last equation. So aluminum is already balanced. So for oxygen, we've got 12 atoms of oxygen on the reactant side and 4 3s are 12 atoms of oxygen on the product side. Similarly, we've got 12 moles of hydrogen atoms on the reactant side and 4 3s are 12 moles of oxygen atom on the product side. So aluminum, oxygen, and hydrogen all balance out in this equation, making option D the correct option for this question. Question 12. Four different fuels are used to heat a beaker of water for the same amount of time using the apparatus shown. Okay, so this is a calorimetry setup. Okay, the initial temperature of the water and the temperature after heating by the fuel are recorded. Which fuel releases the most heat energy? So this will be calculated by looking at the maximum difference in temperature that we have with either of the fuel. So temperature after heating minus initial temperature will give us the difference in temperature, and the fuel with the greatest temperature difference will have the greatest amount of heat energy released. So 46 minus 17 gives us a value of 29. 52 minus 24 gives us a value of 28. 61 minus 26 gives us a value of 35. And 62 minus 30 gives us a value of 32. So out of these, the maximum temperature difference is 35. So this makes option C the correct option for this question. Question 13. An excess of calcium carbonate reacts with dilute hydrochloric acid. The volume of carbon dioxide produced is measured at regular time intervals. The results are shown as experiment 1. The experiment is repeated with only one change to the reaction condition. The results are shown as experiment 2. So the volume of CO2 has increased. So if the volume has increased, that means the moles of reactants have increased. So the options are: which change is made in experiment 2? The concentration of acid is increased. Uh, an excess of calcium carbonate is reacted. So if an excess of calcium carbonate is reacted, that means it does not depend on calcium carbonate, but it depends on how much acid is used. If the concentration of acid would increase, then the time taken to produce the gas would be lesser, and there has been no change in time in the beginning. So this is not how we achieve the results of experiment 2. The volume of acid is increased. Okay, if the concentration is the same, so the graph would start off the same, but since the volume of acid would be more, there would be more moles of acid present, so it would react with more calcium carbonate, producing more CO2. So this would result in the experiment 2 observations, or the experiment 2 graph. So this is correct. The mass of calcium carbonate is increased. They have mentioned that it is in excess. Increasing the mass will have no effect. The calcium carbonate is powdered. Again, it is in excess. It will have no effect on the volume of CO2 produced. So this makes option B the correct option for this question. Question 14. When sulfur is heated, it undergoes a dash change as it melts. If it is melting, it will undergo a physical change, not a chemical change. So this eliminates options A and B. Next, further heating causes the sulfur to undergo a dash change and form sulfur dioxide. So that means it is reacting with oxygen. And when it is reacting with oxygen, it is changing chemically and not physically. Which words complete gaps 1 and 2? Gap 1 is a physical change, gap 2 is a chemical change. So this makes option C the correct option for this question. Question 15. Four statements about the effect of increasing temperature on a reaction are shown. The activation energy becomes lower. No, the activation energy will only change by the use of a catalyst and not by changes in any other conditions. So this statement is incorrect. The particles move faster? Yes, because an increase in temperature results in the particles gaining kinetic energy and therefore moving more quickly. There are more collisions between reactant particles per second. Yes, because the particles are moving more quickly, there would be a greater frequency of collisions between the particles. There are more collisions which have energy greater than the activation energy. So if the number of collisions has increased, so the number of collisions between particles that have energy greater than the activation energy would also increase. So this is also correct. So only statement 1 is incorrect. 2, 3, and 4 are correct, making option C the correct option for this question. Question 16. An example of a redox reaction is shown. Zinc metal has an oxidation state of 0, reacting with copper 2 positive ion, producing zinc 2 positive ion, and copper metal with an oxidation state of 0. So zinc atoms have been oxidized and copper ions have been reduced. Which statement about the reaction is correct? Zinc is the oxidizing agent and it oxidizes Cu2 plus. No, zinc reduces Cu2 plus. So zinc is a reducing agent. So zinc is the oxidizing agent? No. Zinc is a reducing agent? Yes, and it oxidizes copper 2 plus ion. If it is a reducing agent, it would reduce the species it reacts with, not oxidize it. So zinc is a reducing agent? Yes, and it reduces Cu2 plus? Yes. So this makes option D the correct option for this question. Question 17. When bismuth 3 chloride BiCl3 reacts with water, a white precipitate of bismuth 3 oxychloride BiOCl is formed. The equation for the reaction is shown. The reaction is in equilibrium. Which changes causes a white precipitate to dissolve? So the white precipitate is BiOCl, and the changes that would make it dissolve would be if the equilibrium moves in the backward direction. So adding acid, if you add acid, you are increasing the concentration of H positive ions. This would result in the equilibrium shifting to the left. So this is correct. Adding water. Adding water would increase the water present in the reactant side. This would result in the equilibrium moving forward, producing more of the white precipitate of BiOCl. So this is incorrect. And the last one, adding sodium chloride. If we increase the chloride ion concentration which is present in the product, the equilibrium will shift towards the left, decreasing the concentration of the white precipitate of BiOCl. So, since changes 1 and 3 are correct, option B is the correct option for this question. Question 18. Element X forms an oxide that neutralizes sulfuric acid. So, this is a basic oxide. Which row describes X and XO? So X has to be a metal and XO is a metal oxide because they are basic in nature and they will neutralize sulfuric acid. So element X is a metal, eliminating options C and D. And nature of oxide XO is basic, not acidic, eliminating option A and making option B the correct option for this question. Question 19. Information about the solubility of salts is shown. Chlorides are soluble except for lead 2 chloride and silver chloride. Nitrates are all soluble. Sulfates are all soluble except for barium sulfate and lead 2 sulfate. Okay. Aqueous solutions of which two compounds would produce a precipitate when added together? Barium nitrate and calcium chloride would produce barium chloride, which is soluble, and calcium nitrate, which is soluble. So, no precipitate. Copper sulfate and zinc nitrate will produce copper nitrate, which is soluble, and zinc sulfate, which is soluble. So, no precipitate. Potassium chloride and sodium sulfate would form potassium sulfate and sodium chloride, both of which are soluble, so no precipitate formed. Lead nitrate and magnesium sulfate would produce magnesium nitrate, which is soluble, and lead 2 sulfate, which is not soluble. So, a white precipitate of PbSO4 will be observed when these two solutions are mixed together, making option D the correct option for this question. Question 20. The equation shows the reaction between hydrogen and oxygen. So 2 moles of hydrogen react with 1 mole of oxygen, producing 2 moles of water. The bond energies are shown. Which row shows the energy change and the type of reaction? So the bonds that are broken are 2 bonds of hydrogen, hydrogen, single bonds, 1 oxygen, oxygen, single bond. So this would be 2 into 436 and plus we would have 495. So in total, this would give us a value of 1367. This is the total energy that is required to break all the bonds. And the energy required to form all the bonds are, first of all, let's find out the bonds. So there are 2 moles of water. 1 mole of water has 2 OH bonds. So 2 moles of water will have 4 OH bonds. So this would be 4 into 463, which would give us a value of 1852. So bond breaking is endothermic. The value would be positive. So this would be positive 1367. And bond making is exothermic. So this would be negative. This would be minus 1852, giving us a net value of negative 485 kilojoules per mole. So negative means the reaction is exothermic, eliminating options B and D, and the value is 485, not 441, eliminating options A and making option D the correct, no, 485, making option C the correct option for this question.